Alrighty, welcome back everybody. It's your main math manager Shane coming to you live from Summit Academy. In this video, we're going to be still working with those polynomial functions. Again, previously we've been talking about how to write those equations, how to come up with the end behavior, how to get those key parts of those polynomial functions, I should say. But we're just kind of talking about how to actually write those equations. So, on that warm-up, what we're doing is similar to what we kind of ended with, but we're trying to solve for a, meaning I'm trying to come up with what that full equation is going to be. So it says for the warm-up, it says a polynomial function goes through the points and then has 3 x-intercepts. I know these are x-intercepts because the y values are 0. So it goes through the point -8, 0, -1, 0, and 5, 0. So those 3 are x-intercepts, and then it has this additional point of 6, -196. So write the equation that goes with, write the equation that goes with the function. I should say, write the equation that goes through those points. Anyways, so a little bit of a typo there, but that's okay. Mainly focusing on writing out our general equation, so I can use those x-intercepts to come up with, our starter equation. So I'm going to say f of x equals, I don't know what a is, our leading coefficient, but what I do know is I can take the opposites of these x-intercepts. So I'm going to say I have x plus 8 times x plus 1, and I can say I have, make sure it's a plus, and I can have x minus 5. So I know that these are my 3 x-intercepts, and I know I just have to take the opposite of them to kind of write out that factored form. So I already have 95% of my equation just by writing out those 3 pieces. However, I need to use this additional point to be able to substitute in and solve for a. So that's what I'm going to do. I'm going to say, okay, let's take and substitute it in. So I'm going to say substitute. Actually fix my pen here. Hold on one second. All right. Anyways, so let me substitute in. Substitute. Let's say our point. Again, our ordered pair is 6, let's say 6, -196, which we know is x, f of x. So what I have to substitute in, I'm going to say x equals 6 and f of x equals -196. So what I can do is I'm going to replace that in my equation. So I'm going to say, all right, I have, instead of f of x, I now have -196 equals a. And we're going to say times 6 plus 8 times 6 plus 1, and we can say times 6 minus 5. Alright, so now that we have it plugged in, or excuse me, substituted in, I'm going to say, okay, this 3 sets of parentheses, I'm going to actually type into Desmos. So let me underline it. I'm going to say, hey, not including the a, but that entire right side, meaning those 3 sets of parentheses, I'm going to say type in Desmos. So what it looks like is this. I'm going to type it in exactly as it looks. I'm going to say parentheses 6 plus 8 times parentheses 6 plus 1 times parentheses 6 minus 5. So notice how I make it look exactly like it looks in my problem. And so now, instead of these sets of parentheses, instead of doing calculation, I can use the technology that I have in front of me and use it as a tool. So I'm going to say, all right, that's going to be 98. So I just bring it down. So I say, okay, left side is -196. I say equals a times 98. I triple check one more time. Yeah, it's a 98. Okay. So then that's what we're going to divide both sides by. So I'm going to set it up like this. I'm going to say divided by, again, both sides divided by same number. I'm going to say 98. So all together that can be, again, I can leave that as a fraction, but I'm going to say negative 196 over 98. You can also say negative 2, that also works, but that's equal to a. Make sure you're following that last step though. Our last step is to take that value of a and plug it back into our original equation. So now I'm going to say, hey, our final equation is what I'm going to write in, but I can write it down here as well. I'm going to say f of x equals, I have negative 196 over 98 times, let me try to write that a little bit better actually. I'm not sure why my pen's being weird. Alright, so we said negative 19, keep doing that, 96 over 98. But I'm going to say, alright, I have parentheses, I have x plus 8 times x plus 1 times x minus 5. So that's going to be our full equation, and I can check as well on my graph. So let me type it in this little answer space here first. So I'm saying the same thing. Negative 196 divided by 98, parentheses, x plus 8 times parentheses x plus 1 times parentheses x minus 5. Alright, so before I submit and get an answer, I need to check my answer. So graph it out. It's going to have this crazy looking graph, but mainly what we're going to look at is, hey, does it go through that extra point? And so what I can do is I can graph out 6 comma negative 196. I can label it so that way I can find it a little bit easier. But I have to make sure that my graph goes through that point. And so, if I'm unsure, I can keep zooming in, but notice how, it doesn't change. It doesn't go, to the left or the right. It goes directly through the center of that point. So I'm going to say, hey, that's going to be our checking point, besides obviously the points of our x-intercepts, but those are pretty easy to get. The main point we want to look at is, hey, did our curve, meaning our polynomial function, did that go through my extra point that I had? All right, so that's going to be our solution for that. So you always want to check to make sure, hey, does that curve go through that extra point? Good morning, Summit Academy. Okay, so and make sure you're just checking on the graph to make sure that you have your correct points. Make sure it goes through that, mainly that extra point, because that's the point that we had to use to solve for it. Okay, now that we have our function, we're good with that. So that's what we're practicing. Students will, in writing, represent functions in 3 different forms, whether it's a graph, the equation, or the table, using that language of math. So it says this. It says polynomial function can be represented in those 3 ways. So first we talk about the graph, then we talk about the equation, and then lastly we'll talk about the table. So given the scenario to represent given the following scenario, represent the polynomial function in 3 different ways. All right, so same kind of thing. Let's come up with what the equation is. I'm going to say, all right, I have my polynomial has x-intercepts at 2, 0, 0, 0, and a double root at negative 3, 0. So let's come up with that general equation first.
Can I get a water for Joseph Ramirez as a guest?
Yeah. Okay, sorry about that interruptions on this video, but that's okay. So moving on, let's write out our general equation. So when I say I have f of x equals, I'm going to say I don't know what a is, go through the points. I have x minus 2 times x itself, and I have a double root at x plus 3. I need to have something squared. There you go. All right. I need to figure out why my pen's being so weird, but we're still good. All right. So it goes through the point, extra point of negative 1, 4. So I'm going to say let x equal negative 1 and f of x equals positive 4. All right. So in my equation, I'm gonna say 4 equals a times negative 1 minus 2 times negative 1 times negative 1 plus 3, and then squared. And it is very important that you keep those values in the right spaces. So I'm going to type in that right side. Actually, I'm going to make that a label as well. That way we are good. So I'm going to say this right side right here, type in Desmos. Again, a lot of people make mistakes here. They try to just type it in the entire equation. That's not helpful. I'm just typing in that 3 sets of parentheses. So I'm negative 1 minus 2 times negative 1 times negative 1 plus 3. All right, so altogether that's going to be 12. So that's what I'm going to write underneath. So I have 4 equals a times 12 as my equation. And my last step is to divide both sides by that number we just found. So I'm going to say divide both sides by 12. Again, if you want to simplify your fraction, you can. I'm not going to take off points if you just leave it as it is because, you know, for the most part, as long as we have that full equation, we are good. So there's a. Take that value of a, and we're going to plug it back into our original equation. So draw that arrow to show, hey, where it's going up here. And I can write out what that equation is. So I'm going to say f of x equals, I'm going to say 4 over 12. Try to write that again. I don't know why it's not working. There we go. Times x minus 2 times x plus 3 squared. So that's going to be our final equation for this scenario. But we have to always check before I type it in. Or actually, I guess I can type it in here, but I need to make sure that it is correct. So I'm going to type it in. I'm going to copy and paste it into the graph to see if it goes through those points that I needed to go through. So you want to make sure that you're graphing it out and checking, because, you know, a lot of people are just going to say, hey, it goes through the x-intercepts, it's good, but we are mainly looking at, hey, does it go through that extra point of negative 1 comma 4? So I'm going to look for that point, click label if I don't see it right away, but it's right here. Again, as I not click at that point, as I get zoomed in closer and closer, again, it's not kind of moving. I'm not straying away from that point. That curve goes directly through that point, which is a good thing. And let's see if it works out. So it says, you know, always go back to that original equation or original sentence. A polynomial that has x-intercepts at 2, 0, 0, 0, and a double root at negative 3, 0. So I know I am good. So always graph it out to check, so that way you know you're good. All right, so that's one of the representations of a polynomial function is the equation, and we can also look at that graph. So let's talk about the table. So it says here's our equation. Polynomial can be expressed in those 3 ways. Let's create a table. So again, we already have that scenario. So I don't know why it says below, but it should say below. But it says also you can substitute any number for x. So what I can do is I can actually graph out that function. And if I want to find out, hey, what's that value at that point, I can type it in. So what I mean by is I can choose whatever value I want. So let's say if I typed in negative 2, what happens? Well, we get 2 2/3. Or if we type in negative 4, what do we get? We get 8. So that's an easy point to type in. So notice it's not one of the additional points, but it is a point on our graph. Again, that creates the order pair, negative 4, comma 8. I can find it on my graph. Notice how it goes directly through that curve. Or sorry, that curve goes directly through that point. So I can just make a list of order pairs. So let's make a list here. I have negative 3, comma 0. As one of my x-intercepts, I have 0, 0. and I have 2, 0. It told me I went through the point -1, 4. And again, you can play around with different points or whatever you want, but you can choose whatever x value you want, and what comes out is the y value. So for example, I tried -4, and what came out was 8. So I like to use integer values, but again, you can always click and drag those different values to find different points. But again, you can choose whatever amount you want. So if you wanted a different number, so let's say you don't like negative numbers, you like positive numbers. So let's try +4. What comes out? Big number. What about positive, let's say 1 or 3? Yeah, 3 is reasonable. So again, notice how I'm coming up with these numbers. I'm choosing these numbers. Again, your independent variable is x, so that means I can choose whatever I want to plug in, and what comes out is dependent on what I plug in. So again, come up with some different numbers, try filling it in. Again, if you want to do maybe one more, try to find one that has a whole number output as well. No decimals, that way it's a little bit easier to type in. But again, play around with it. That is just that function notation. I'm choosing a value for x, plugging it in, and this only works. Let me actually, hold on. Did I have that squared on the end? I do. Okay. Let's pull that back up. Again, choose your values, plug in, whatever comes out is that y value. All right, moving on. All right, so let's graph it out. Again, if you wanted a new slide of the graph, and this is what it looks like. Again, we'll talk about those key features here in a second, but for the most part, we're looking at those, mainly those x values, meaning our x-intercepts, our roots, solutions, or zeros. We're looking at that shape of the curve, kind of looks like a W shape. So it tells me, hey, my leading coefficient is positive, which checks out because 4/12 is positive. I have an even degree because I have 1, 2, 3, 4 as my total number of roots. Again, I can talk about the end behavior as well. As I go to the far left, it goes up. As I go to the far right, it goes up. But again, those are just those key features of the graph. So now you try. So I want you guys to try this on your own, but I want you guys to try, given that situation, come up with what the value for A is going to be. So how about this? I'll get you started. Since it has a double root. So it says a polynomial has x-intercepts at 2, 0, 2 double roots at -3 and -1, and it passes through that point. So I'm going to say my general equation to start is going to be equal to, I'm going to say I don't know what A is, but I have x minus 2 because I have x plus 2 in my point, and then I have 2 double roots. So I'm going to say I have parentheses x plus 3 squared, make sure that's a plus, squared, and I have my other set of parentheses is going to be, or my other double root is x plus 1 because I have -1 as one of the x-intercepts. It passes through that point of 4, 3. So what you could do here, and we'll say let x equal 4, and let's say f of x equals 5. So what I would suggest you do is pause that video, try it out on your own. Again, try to get that equation to go through the graph, so that way you're good. All right, so now that you got through, let's check your answer. So on here, I'm going to substitute those in. So I have f of x is 5, right side is a times 4 minus 2. There you go, 4 minus 2 times 4 plus 3 squared times 4 plus 1 squared. Try that again. All right, so let's type in that. I'm going to make that note real quick. All right, so we're going to say, hey, this entire right side 4 minus 2 times 4 plus 3 times 4 plus 1 squared. All right, so big, oh, sorry, let me make sure I type it in exactly as it looks. So pretty big number here, that's okay. We're gonna say it's typed in exactly as it looks, so we know we're good. But like I said before, we're always gonna check to make sure it goes through those right points. So I'm gonna say, all right, all together, that's gonna be, I'll write it like this, change the color actually. I have 5 equals A times 2,450. All right, so that's going to be my equation. I'm just trying to solve for A. So last step is to divide both sides by that number we just got. So 2,450. Again, I suggest you leave it as a fraction. That way you don't have to simplify. Keep it simple for yourself. So I'm going to say 5 over 2,450 is equal to A. Same step as always. Make sure that you're plugging A back into your original equation. I'm going to say drag this up, substitute it back into your original equation, and write out what your original equation should be. So I'm going to say my original equation is going to be f of x equals 5 over 2,450. I'm going to say times x minus 2 times x plus 3 squared. I have x plus 1 squared. All right. So actually, let me box that in. I believe this is going to be our answer for this situation. All right. So let's type it in. I have f parentheses x equals, make a fraction, 5 over 2,450. Parentheses x minus 2, parentheses x plus 3 squared, and parentheses x plus 1 squared. All right, so let's check to see if this is right. Again, I graph it out on my graphic calculator. Weird looking function, but let's check it out. So I'm mainly looking for, does it go through the points of, where's it at here? We have negative 3 comma 0, we have negative 1 comma 0, and we have 2 comma 0 as well. So it does go through those points, which is good. But we mainly are looking for, that extra point. That extra point really tells us, is our graph correct? Which, as it looks, as I zoom in, it's triple checking, it is good. My curve goes through that point that it says it's supposed to go through. So I know my equation is correct. Let's get that table represented as well. I can graph it out if I need to, but I can have those points. So it says it went through 2 comma 0, it went through negative 3 comma 0, it went through, is it negative 1? Is that right? Yeah, negative 1 comma 0. So you could type in your given x-intercepts, type in the extra point that you were given, and come up with one more additional point. So I can try some different numbers. Let's say f of, I don't know, let's say, what's 0? F of 0. Now, let's try f of 1. What about negative 2? What about 50? It's too much. What about 5? Might have some rough numbers here. Oh, actually, you know what? That's perfect. That's fine. Not too long of a decimal, but I just tried some numbers. So I just went through some of the numbers, and I can get an ordered pair by plugging in those points. So practice and play around with those. Try to get an additional point. So I plugged in 6. What comes out is 32.4, which is an ordered pair on that graph. I can check to make sure it goes through. 6 comma 32.4. Let's see if it's on my graph anywhere. Yes, it is. It is right here. Again, notice how it goes directly through that point, so I know it's good. So try, again, replace whatever value you want for x into your equation. What comes out is your y value. Again, come up with an additional point for that one for yourself. All right, and then here's the graph, again, getting our different key features for that, but that's our main part that we are getting at. All right, so same kind of thing. Try coming up with what your scenario is, or excuse me, your function. So I'd say a polynomial that has x-intercepts at 0, 0, negative 4, 0, and negative 2, 0, but it passes through that point of 5, 5. So I would suggest I want you guys to try it at this point. So I set up the last one, so if you need to go back, maybe check those steps on how I get my setup, I would suggest going back and checking. You can always rewind and rewatch that part. But what I want you to do is try coming up with the equation for this situation. So please pause that video, try it out on your own. Man, a bunch of interruptions today. All right, so once you try that out on your own, again, get your equation, put your equation in, check to make sure it goes through that point 5, 5. Once you have a list of ordered pairs, get an additional point. So you'll type in the points of 0, 0, negative 4, 0, negative 2, 0. You'll type in 5, 5, and then I need one additional point. So choose that x value, plug it in, see where you get. Make sure the graph is good. And then your exit ticket is just coming up with through your own. Again, you can try it out for yourself. Again, plug in some different numbers, or if you need help with this one, I can help you out, but the graph is on the next slide as well. So try these out. Again, make sure you can ask questions as they come up. Be sure to check your work on Desmos. And as always, super slam that subscribe button.